What is the velocity change per second when acceleration is 7 times 10 to the power of negative 5 meters per second per second? What is the velocity change when acceleration is 7 times 10 to the power of minus 5 meters per second per second? Number 2, based on this acceleration, what is the time it takes to reach a speed of 90,000 meters per second? So what does it mean to say that acceleration is 7 times 10 to the power of negative 5 meters per second per second? By definition, acceleration is change of velocity divided by time. Change of velocity is final velocity minus initial velocity divided by t final minus t initial. Final velocity minus initial velocity divided by, let's assume t final is t. T final is the time it takes to reach the final velocity vf. And usually we start from 0, so we have t minus 0. So our acceleration is v final minus v initial divided by time. Do not forget, acceleration is a vector. So when we are told that our acceleration is 7 times 10 to the power of negative 5 meters per second, it means that that's how much our velocity is going to change every second. That is how much our velocity is going to change every second. Don't you agree? This is a very tiny, small number. Very little. So what is the catch? The catch is that you really need the thrust for a very long time. How long? Let's see. By definition, acceleration is change of velocity in meters per second divided by time in seconds. So acceleration is final velocity minus initial velocity divided by time in seconds when we reach the final velocity minus time at the start. So we get acceleration is v final minus v initial divided by time. For convenience, we have assumed that this is equal to 0. So what is acceleration? It is just acceleration is equal to vf final velocity divided by time. If acceleration is equal to final velocity divided by time, then time is equal to final velocity divided by acceleration. We are given the final velocity. Final velocity is 90,000 meters per second. We are given the acceleration, 7 times 10 to the power of negative 5 meters per second. Substitute those numbers and you get your time in seconds. You get your time in seconds. Do not forget, meters per second, they cancel out. So what do we get? Our answer in seconds. And so we get this big number, 1.2857 times 10 to the power of 9 seconds. That's a very big number. So what we can do is we can convert those seconds into years. How do we convert our seconds into years? 1 year is 365 days and 1 day is 24 hours and 1 hour is 3600 seconds. So when you do that, you get 40.7697 years. It's a very long time, for almost 41 years before you get a speed of 90,000 meters per second. So where is this application? This application is found in xenon ion propulsion. It is mostly used in spacecrafts. Again, we are not going to get an immediate change. And this is Mathew signing off, and I want to wish you all the best. Good luck.